Hello everyone, we've been asked to prove this identity. The left hand side is given to be equal to sine theta minus 2 sine cube theta, the whole thing divided by 2 cos cube theta minus cos theta, and we'll have to prove that this whole expression is equal to tan theta. Now in this video we're going to try and prove this, and before attempting to do it, let's clear ourselves. Sine cube theta is nothing but sine theta, the whole thing raised to the power 3. So we can factor out sine theta in the numerator from both the terms. There are two terms and both have sine theta as common. So let's factor out sine theta, and what we have within the brackets now is 1 minus 2 sine squared theta, and the denominator, the same thing. In the denominator, this whole thing is divided by, we factor out cos theta, and what is within the brackets would be, so let me write the factored out term here, cos theta, and within brackets we have 2 cos squared theta minus 1. Alright, and now we'll have to see what we can do with this. Just that I can write 2 sine squared theta 2 times, like this can be written equal to sine theta multiplied by 1 minus sine squared theta minus sine squared theta. Why am I doing this? I am doing it because I am recalling the Pythagorean identity. Sine squared theta plus cos squared theta is equal to 1. We have proved this rigorously in one of our videos in the Math Decoded channel, but it's nothing. I can just quickly say what it is. How do we define sine theta? It is the measure of the opposite by hypotenuse. And how do we define cos theta? It's the measure of the theta's adjacent side by the hypotenuse. And what is sine squared theta plus cos squared theta? It is the square of both these things. Just concentrate in the numerator. We have opposite squared plus adjacent squared. And what is that equal to? Opposite squared, the length of the opposite, the whole square, plus length of the adjacent, the whole square is hypotenuse, right? So we have this hypotenuse squared and hypotenuse squared, which gets cancelled and which is equal to 1. Of course, you can refer to that channel in our refer to that particular video in our channel. Now let's use this identity here. So I can rewrite this as 1 minus sine squared theta is equal to cos squared theta, right? Or 1 minus cos squared theta is equal to sine squared theta. So here in the numerator, instead of 1 minus sine squared theta, I can write cos squared theta. And similarly, let me do the denominator before I substitute all that. Denominator is cos theta, and I'll split and write cos squared theta as cos squared theta plus cos squared theta minus 1. Now you have a value for 1 minus cos squared theta. So let me somehow manipulate this and bring 1 minus cos squared theta. Nothing, I'll just have to take away the negative sign, or take away negative 1 as a common factor. And what would I get within the brackets? So negative 1 into this would be equal to minus cos squared theta plus 1, right? It's the same as the one which was written before. We have just done this because I can, instead of 1 minus cos squared theta, here I can just write sine squared theta in my next step. So let me do it now. So this is equal to sine theta by cos theta, and into what is 1 minus sine squared theta? Cos squared theta minus sine squared theta by, once again, cos squared theta minus sine squared theta, because 1 minus cos squared theta is sine squared theta. So these two get cancelled, and we just have sine theta by cos theta, which is equal to tan theta, and which is our right hand side of the identity which was given in the beginning. So we have proved whatever we had wanted to prove. I hope you followed. Thank you.